Hi, now in this tutorial what I want to do is just introduce you to stationary points. So what is a stationary point? Well, if you've got a curve, say something of the form y equals f of x, then stationary points are points on the curve where the gradient is 0. That's if you drew a tangent to a point on the curve, it would be parallel to the x-axis. Now if you took a point like this on the curve and drew a tangent to it, the tangent would be something like that. Clearly not parallel to the x-axis. And the same applies over here. If you drew a tangent at this point, it would be something like that, not parallel to the x-axis. So where are there points on the curve where the tangent is parallel to the x-axis? Well, first of all, there's one here. If you drew the tangent, there it would be. Okay? Parallel to the x-axis, would have a gradient of 0. And there's another point on the curve that is similar to this one. It's over here. Now points like this are often referred to as maximum points. Maximum stationary points, if you like. You'll also notice though that I've put in the word local because some people will call them local maximum points. Why is that? Well, purely because at this point the y value here isn't the largest value. You'll see that there's points up here, for instance, that are much greater than the y value here. And when it comes to this point, clearly y values from about here onwards are greater than this y value. It's called local because in this region close to that point, this y value is greater than all the y values around it. And the same applies to this point here, this region. So we've got a local maximum. Now let's have a look at some other stationary points. This one down here. If you drew the tangent parallel to the x-axis, its gradient would be 0. And you've got another similar point to this one on the curve. It's over here. And points like this are called minimum points. There you go. And again, they're called local minimum by some people because in the vicinity of your point, this y value here is the smallest y value when compared to the y values just surrounding it. The same applies here. So, a local minimum point. Now you'll notice that for parts of the curve that look like this and look like this, the curve seems to bend back on itself. So some people refer to these stationary points as turning points. So expect to see that in some textbooks. Now we've also got some other stationary points on this curve. There's one here. If we drew the tangent, it would look like that, parallel to the x-axis. And there's another one. Here it is, over here. If you drew the tangent, it would be flat. It would have a gradient of 0, it's parallel to the x-axis. Now these aren't maximums or minimums, so what do we call them? Well, they're called points of inflection. And you'll see that this particular point of inflection here is over here on the curve, and this one appears over here. So, get used to the terminology. Stationary points is the collective name for any of these types of points. We've got our maximum, we've got our minimum. These are called turning points, and we've got our inflection points. So in summary, okay, what we've got is that at stationary points, that's these points we have here, the gradient is 0. Now how do we calculate gradient? Well, gradient, if you've got an equation for a curve in the form y equals f of x, you get gradient by differentiating the curve with respect to x, finding dy by dx, or some of you might know it as f dash x. And if we put that gradient function equal to 0, so if we do dy dx and equal to 0, or f dash of x and equal to 0, we're going to get an equation, and if we solve that equation for x, it will give us the x coordinate of the stationary point. And once we've got that x coordinate, we can feed it back into the equation up here and get the corresponding y coordinate. So what this will allow us to do is to find the coordinates of stationary points. Now in my next tutorial, what I'm going to show you is how, when we've got stationary points, how we can figure out, if there's no graph drawn, whether they're a maximum or a minimum or a point of inflection. So I hope you'll have a look at that, and that brings us now to the end of this particular tutorial on what a stationary point is.